Assalamu alaikum. My name is Bisma Nisar. My roll number is 201839. Today I will talk about lab number 4 of digital signal processing, in which we analyze discrete time linear time invariant systems. Task A. How would you differentiate between a signal and a system? Explain the key characteristics of each and provide examples to illustrate their roles in the context of signal processing. In signal processing, a signal is a time varying or spatial varying quantity that carries information. It can be electrical, acoustic, or optical in nature. A system, on the other hand, is a mechanism that processes the input signals to produce an output. The key characteristics of a signal is its information content, while a system is defined by its behavior is transforming or manipulating signals. For example, an audio signal like music is a signal. A speaker or amplifier represent a system. ऑडियो जो है वो सिग्नल को रिप्रेजेंट करती है लाइक के म्यूजिक एंड a speaker or amplifier represent a system that processes these signals to produce sounds. टास्क बी में हमारे पास क्वेश्चन नंबर 2. How does linear time invariant LTI system play a crucial role in digital signal processing, considering their mathematical simplicity, adherence to the superposition principles, and efficiency in frequency response analysis? आंसर है हमारे पास इसका linear time invariant LTI systems are fundamental in digital signal processing (DSP) due to their mathematical simplicity, adherence to the superposition principles, and efficiency in frequency response analysis. These systems exhibit conscious behaviors over times and possess linear and shift invariant properties, allowing for straightforward mathematical representation. The superposition principle enables the analysis of complex signals by decomposing them into similar components. Additionally, their frequency response analysis is efficient, providing insight into how the systems respond to different frequencies, circle for designing and understanding digital filters in DSP. Task C. What are the common methods for signal decomposition, especially for focusing on techniques like impulse decomposition, step function analysis, even-odd decompositions, and Fourier analysis? Explore how these methods contribute to breaking down signals and their applications in signal processing. आंसर है हमारे पास कॉमन मेथड फॉर सिग्नल डिकम्पोजिशन इंक्लूड impulse decompositions, step function analysis, even odd decomposition, and Fourier analysis. Impulse. First of all, impulse decomposition involves expressing a signal as a sum of scaled and time-shifted impulses. Step functions analysis break down signals based on their step response. Even odd decomposition separates signals into even and odd components. Fourier analysis decomposes signals into a sum of sinusoidal components, revealing their frequency contents. These methods play a circular role in signal processing, allowing for a better understanding of signal characteristics and facilitating the design of filters and other processing techniques. Task D. What is convolutions and how does it play a significant role in digital signal processing systems? Explore the fundamental concept of convolution and elaborate on its importance in various DSP applications such as filtering, signal processing, and system analysis. Convolution is a mathematical operation that combines two signals to produce a third representation, the integral of the pointwise multiplication of the input signals. In digital signal processing, convolution play a circular role in applications such as filtering, signal processing, and system analysis. It is fundamental for understanding how signal interact with system, enables tasks like convolutional filtering to extract specific features or analyze the response of systems to input signals, making it a cornerstone in various DSP algorithms and applications. Task C. Task C. Question 1. When do we correlate two signals, and what are the applications or scenarios where signals correlations in circular in various fields such as communication system, radar, and sonar, imaging, image processing, biomedical signal processing, control system, wireless communication, and seismic signal processing. We correlate two signals when we want to measure the similarity between them or identify patterns of interest. Signal correlation is a circular in communication systems for demodulation and error detection, radar and sonar for target identification, image processing for pattern recognition, biomedical signal processing for event deductions, control systems for feedback analysis, wireless communication for channels estimations, and seismic signal processing for identifying subsurface structures. Correlation is a fundamental tool across various fields, aiding in tasks that involve matching or comparing signals for meaningful analysis and discussion making. In task 1, we define a function that is convolution graphs. Then we take a signal x from some user and also take a signal h from some user h. Then we convolute both the signals x and h. Then we use figure commands for producing figures. Then use subplots 3, 1, 1. Then use stems for producing x. Then use title input signal. Then subplots 3, 1, 2. Then stem for producing h signal, then use title, then again use subplots 3, 1, 3, and then use stem for producing convolution of both x and h, and let we give the title output signals, and then end. Output signal is like this: input signal x, input signal h, input output signal y is equal to x multiply h. In task 2, first we add T start, which is the combination of T1 and T2. Then produce T and then we find difference between T1 and T2. Then we use figures, then stem commands, then use X label for labeling in X-axis, then use Y label for labeling in Y-axis, then use title, then use axis, then use grid, and then we use pass commands. Again we define input signal that is T1 range from -1 to 1. रेंज हमारे पास दी हुई है -1 से 1. Then use exponential define T2, and in last we convolve both these signals by using flip and side methods. At the end we get output like this. In few seconds we got all then samples. Define the output signals T1 -1 से 1, x1 exponential minus T1 पावर 2, T2 -2 से 2 और उसकी रेंज हमें दी हुई है 0.1, x2 हमें दिया हुआ है T2 मल्टीप्लाई 2 पावर 2. परफॉर्म द कन्वोल्यूशन एंड शो रिजल्ट्स. YT कन्वोल्यूशन फ्लिप स्लाइड्स x1 T1 x2 T2. और दी हुई हमें कन्वोल्यूशन यूजिंग फ्लिप्स एंड स्लाइड मी. In task 3, first we define a convolution, then define NYB, NYE, NY, and in Y we convolve X and H. Now we define a range of X, then define range of NX, then define range of H, then define range of NH and X. Last we convolve X, NX, H, NH and use stem commands, and in last we give title. As a result we get an output like this. Response of a system to input signals title. आउटपुट है हमारे पास response of system to input signals S of n shown in figure. In last task, first we define x, then in y we convert both these XFH. Then we use subplots, then titles. 311 stems हमें दी हुई है, लेंथ हमें दी हुई है x माइनस वन और x, टाइटल हमें दिया हुआ है इनपुट सिग्नल। सब प्लॉट दोबारा से अगेन किया 312, स्टेम हमें दी हुई है 0 और लेंथ हमें दी हुई है h माइनस वन और h, टाइटल हमें दिया हुआ है इम्पल्स रिस्पॉन्स। सब प्लॉट किया हमने 313 को, सिस्टम एन वाई। Shifted use figures, then use stems, give title to shifted input signals, again use subplots and again use stem commands, then why shifted give tasks. As a result, an output like this. Input signals हमारे पास फर्स्ट जो हमने सब प्लॉट किया था ग्राफ में, वो उसमें कोड में, उसका ग्राफ ये है। इम्पल्स रिस्पॉन्स में जो हमने सब प्लॉट्स हमने जो दिए हुए थे, टाइटल्स दिए हुए थे, उसको जो एक्स एक्सिस पे वाई एक्सिस पे दिए हुए थे ये शो हो रहे हैं। आउटपुट सिग्नल में भी एक्स एक्सिस और वाई एक्सिस पे जो सब प्लॉट्स हमने दिए थे शो हो रहे हैं। शिफ्टेड इनपुट सिग्नल्स जो है हमारे पास सेम ऐसे ही हैं जैसे ही हमने सब प्लॉट्स में एक्स एक्सिस और वाई एक्सिस पे जिस तरीके से हमने शिफ्ट किया था सिग्नल को, और आउटपुट सिग्नल फॉर शिफ्टेड इनपुट के जो आउटपुट आई है, जो हमने इनपुट दी थी उसी की आउटपुट हमारे पास शो हो रही है। थैंक यू सो मच। अल्लाह हाफिज़।